All right, in this lesson right here, what we're going to do is take a look at the game loop class. Now, with any game, or just about any game, if you will, there's a game loop.
Yep.
That's right.
And game loops are, well, they really are the heart of a game, if you will. Not necessarily the brain, but the heart. I mean, both of those elements are very important.
Oh, yeah.
Now, without our heart, though, we stop functioning.
Yep.
That's right.
That's just all there is to it. So without our game loop, our game will simply stop.
Well,
We'll never
without
even
it,
start.
it'll never start.
It'll never start. Good
Right.
point. So anyways, this game loop is very much like a heart, if you will.
Yes, it is.
And its job, like our heart, how it's just constantly pumping very vital fluids throughout our body, if you will.
Important red stuff.
Yeah, the game loop is kind of pumping in a sense as well. It's constantly looping where it's looking for specific things to take place, and it's taking care of updating stuff as well.
Right.
Of course, what is it looking for in regards to information? Well, it's looking for input from the user.
That's right.
So have you hit a key? Have you said to fire something or to move your character? And then what else is it responsible for? Well, it needs to update your screen because, obviously you're seeing little monsters run around, running in the wall if they're dumb, whatever it may be.
Yeah.
But this information needs to be updated because until it's displayed to you, it's just numbers. It's going on in memory, and that's it.
That's right.
So it's basically in charge of this refresh, and then from there that starts to trickle off, if you will, into all of the other brain elements in regards to some basic AI calculations or maybe even advanced AI calculations.
Yeah, which is where all the classes that we'll create in the later lessons.
So exactly. So we can say that those are going to become our vital organs, including the brain, if you will.
Right.
But we need to start with a heart. Got to have that.
Oh yeah.
Okay?
You gotta have heart.
You got to have heart.
You gotta have a heart.
So
where's yours go?
Yeah, whatever. I'm functioning without one. So we've got Visual Studio open right now with no project, no nothing. We want you guys to see this entire thing from start to finish.
Mm-hmm.
How cool is that? So the first thing we need to do is go ahead and get a project started.
All right. So let's go up to File, New, Project. And we'll select a Win32 console project. And we'll name this Evil Monkeys.
And Dan, why a Win32 console project?
Well, since our game is only focused on alphanumeric output and input, we don't need to have a Windows application.
No, we don't.
So all we need is what I would consider the DOS prompt, the DOS shell, the old
and
style.
representing the students out there. This won't cause a problem later if I'm wanting to port this to the GBA like you guys have done.
No, because we've designed it in such a way that it's easy to plug new components in or replace the old components, and you'll have portability to a different system.
Very nice. Okay, so continue.
So let's press OK. Now, just set a few application settings here.
Look for the checkbox, Make Game.
Where?
Oh, no, it's just behind that dialog box.
Yeah.
Oh, well.
It's an Easter egg. It's a special hidden link.
Button.
That's coming out in a few years from now.
Yeah. Oh, well. Well, anyway, we have our application type. We'll select console application, and we'll have an empty project.
Yeah.
Start afresh. Let's press Finish. All right. So now we have a complete empty slate.
No
We do not have
files,
no source files, no headers, nothing. First, we need to create our main source file. So inside of here, CPP file, we'll call this main.
And this is just a convention that you'll probably find a lot of programmers doing.
Yeah.
It contains the main function.
Yeah.
Which is essentially the start of any C application.
Absolutely.
That's
And if you put it in a file called main.cpp,
it just makes sense.
You'll find it real easy.
Yeah.
In fact, you'll find it quickly.
So we'll just say int main, and inside of here, you know what? We'll just say return 0.
Oh, I'm so excited.
Yeah, I know.
That's the best game ever made.
And it's valid.
Yes, it is. I mean, if we try to compile this, it's happy.
So we've made a game, and that concludes the VTM.
Just wait, did you run it?
No, I'll run it. Ding.
Oh,
Ooh.
yes. The press any key to continue game.
Oh, fancy.
Oh, yeah.
All right.
There you go.
So now we have that. Now what we want to do is create our game class.
Yes.
So what we need to do is go to our header files here.
Now, this is just a reminder.
Yes.
Remember in the last lesson where we took a look at project management, all right? With project management, it's good to break everything up. So now we're going to have our game. So we can go in there and create the header file, then the CPP file.
Yeah, but since we're going to call it the game class,
right?
We're just going to put it in game.
Game.
Oh, yeah.
Sounds good to me.
So under header files, we want to create our header first.
Yes.
So we can go right-click, add, new item. Under our header file, we'll just call this game.
The nice part about making your header file first is that you'll know what functionality you need to create inside of your CPP file.
Right. So inside of here, let's go ahead and start defining our game class. First, we can say class game.
Oh,
right?
wait. You missed something.
Yes, we'll include that in a second.
Oh, okay. I'm just thinking for everybody out there, the first step I always do is do the define, the end-def, the
because
define,
like you said in the last lesson, it's a rule.
It's a rule.
It's a rule.
That's right.
So I'll put it in here just to make Dan happy.
Thanks, Joel.
If not defined, game _ age, then we're going to go ahead and define it. And then at the end, what do we put, Buzz?
Well, we probably need to end off our if, would be my guess.
So, and if.
He caught the student not paying attention. He was doing something else. Was I right?
Yes.
It was just a lucky guess.
Whew. Okay, so inside of here, there's, as we just said in the last lesson, last lesson,
Public,
we have our public,
our protected.
Exactly.
Blah, 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 blah.
We want functionality that is available to everyone.
Everyone.
Who makes an instance of this class.
And basically, we want to say, start running.
That's right.
So basically, get our heart pumping. So inside of here, we're going to have a bool. So it's going to return a true or false statement, whether it worked or not, right?
Yes.
And we're going to call this run. And we don't need to pass it anything.
No, it's going to be a void function.
Right, because the game controls everything. We don't need to pass it anything.
Yeah, there's no parameters that
we need. And actually, the run function, when we get inside this function, we're not going to get out of the function until the game is over.
Yeah, so really, it's good.
Yeah.
I don't have a better way to say that.
Yeah.
I mean, either the game will run, or it won't.
Yep.
Well, if you don't have a heart, you just don't function.
Yeah, that's right. So another thing we need is two other protected functions that are sort of private to us, right?
Okay.
So let's define these as well. So under the protected section, we're going to define bool get input.
And this is going to be how we poll to see if someone has pressed a key on the keyboard.
That's right.
And if we get a key press, it'll return true.
Right.
If there is no key press,
it'll return false. And if it does return true, it will put the character that was pressed inside of C.
Okay.
Now, another function that we talked about is the timer update function. So this is going to be called constantly to control the timing of our application and make it go at like 30 frames a second or whatever we want.
And it's also going to be the place where we put our actual game code.
That's right.
When we start defining our classes that will come down the road.
Right, like level update or something.
Yeah.
So inside of here, this is going to pass void. Timer update knows what it needs to do. We don't need to pass it anything. So for now, that's good.
Okay, so we're going to
now define the source for this guy.
Yeah.
So inside of our source files here, we're going to go to add, new item, and we're going to create a C++ file, and this guy's going to be called game. So now we have game.cpp.
Okay.
Isn't this nice? So the first thing we need to do, as a rule, is include our header file. So include game.h.
And again, that's because we need to know inside of this CPP file
about this class.
About the class.
Yeah. That's right.
We need the template.
So the first thing that we're going to do is which one? The game run.
Game run.
Because that's the thing that we're going to be calling from our main.cpp file. So it only makes sense to do this guy first. So inside of here, this is going to, we don't need to pass it anything like we said before. So inside of here, what do we need to do? Well, what we want is for it to say, while...
Oh, there's a loop.
This is going to be a loop. While key, which is the current key that was pressed, does not equal Q loop.
So what's key?
Key is basically what's inside of the loop. We're going to update key value, the variable key, to show what variable was just pressed.
So
where does key come from?
Character type?
Yes. So on top of here, we need to define our character.
Okay.
Character key equals, and for starters, let's initialize it to say space.
Okay.
So inside of here, we can initialize it to space.
We're going to be doing that just to avoid a compiler warning.
Right.
Or error that pops up.
Yeah, an error.
It's not necessarily... You could get away without defining it because... Well,
actually,
no,
you couldn't. You can't get away.
My bad. Please continue, Joel.
So while key does not equal quit. So this loop is going to be running and running and running until the game stops, right?
Yeah. So if we were to call that... If we were to set this up in main right now...
So actually, why don't we do that? Go back to main.cpp. And inside of here, we need to define our class, right?
Okay.
So create an instance of our class. So game, and what can we call this?
Well, we could call it game, I suppose.
Yeah, we could just call it game.
But it's not spelled, it's not the same.
Yeah, it's not the same, and can we see it?
Let's say game heart.
Okay.
But we have a problem here, don't we?
Yeah, because we're cut off.
Yes, we're cut off from the rest of the program. We don't know where the header file is.
We don't know what game is.
Right.
We need to include something.
Yeah, I would guess so.
So include game.h. Dink. So that should work. Let's try to build this guy. Dink. Error. Game run must return a value.
That's because we defined it as bool.
Right. So we're just going to say return true. It's going to work.
It doesn't matter if it does or doesn't.
It's going to work.
It's just going to.
So we compile this guy. It links. It's happy. But it's not going to call this guy yet because all we did is say game heart. We declared an instance of it, but we don't call the run function.
Yeah, because we actually have to specifically
call it. So under game heart, you can call it whatever you want. Dot run.
In fact, it might show up as being a different file, a different variable later on.
Yes.
Yeah, you never know. Crazy things happen.
So let's compile this guy. So that looks good. It runs. Let's run this guy.
And it doesn't say press any key to continue.
And I could type anything on the keyboard right now, and nothing's going to happen.
He is typing anything on the keyboard.
Yeah, he is.
Yes.
But hit Q.
But hit Q. Nothing's going to happen.
Oh, because we haven't figured out how to pull information.
Yeah, we haven't actually pulled for it. That's right.
That's right.
All right.
So let's exit out of this guy. Go back to our game.c. Isn't this nice having the separate files?
It's so clean.
Oh, yeah.
Project management.
By the way, this type of loop in general, if you can't get out of it,
that's called an infinite loop.
And it's bad programming practice.
Mega bad.
But if we can control it, it's good programming practice.
Yup. So inside of here, what we want to do is update the key variable. So inside of here, we can say while not, because remember, our get input function is going to return true or false depending on whether or not it hit it, right?
Okay, so if you hit the keyboard again, it'll return true.
Right. So get input and pass it. Remember, as we did before, in the pointer section, right? We can say the address of key. So we're passing get input the address of key. Dink. So inside of here, what do we want to do? We need to call timer update, right?
Okay.
But for now, it's not created yet, right? So we're just going to create an empty loop. Does that sound cool?
Yep.
So we'll get the get input functionality
in place first,
and then we'll go back and add in the game.
That's right. So now we need to define this get input function. So how do we do this? Very simple. Bool game : get input. We know it's a pointer to a character C. That's great. Now, this is kind of interesting. There's a function that you can call inside of C++ called kbhit.
Okay.
It's in which header file, Dan?
Ooh, geez, con.io?
Yes, nice. So we say if kbhit, and you'll notice it does recognize it. If kbhit, what this means is if we hit a key, then it's going to get inside of this loop, right? Mm-hmm. So what do? We say $C equals, which is what was passed to us, get ch, which just says get the character that was just pressed, right? This is kind of an old school way to do things.
Yeah, this is something that I'm fairly familiar with.
Yeah.
Because this is the way that back in
the olden days.
Which really wasn't that long ago.
Yeah, it was.
No, not really. This was pretty much the only way to do it, unless you wanted to get into some really low-level programming.
Yeah. So this is fine for our purposes. So we'll just say that's cool. And then we return true because a key was hit, right?
That's true.
If it didn't hit, what do we want to do? Return false. Simple enough.
Do we have to include any headers?
Actually, yes, we do. If we try to compile this guy, KB hit, identifier not found.
And get CH.
And get CH, identifier not found. So what do we need to do? Include conio.h. And compile this. Everything's happy.
Very nice.
Hey.
That's con.io is just a C header from back in the day, which was for console input and output.
It contains all sorts of useful functions that you can use for that stuff.
Look it up in your help file.
Look it up in your help file. You sound like an advertisement. So, with that set up, now it's going to exit out of this loop if it returns true, right?
Okay, so we sort of have two loops going on.
Yes, we do.
One will loop
until the game is ended.
Yes, until the game ends. So it'll enter this loop, then it'll enter into the second loop, which will keep looping
until a key is pressed.
And then you'll exit that loop, but you'll loop back again because you're in the big loop.
Unless you press the character Q.
Okay.
Whew, a lot of information to get across here. So let's press Control F5 just to run this guy.
How's your heart doing?
The pain. So now, of course, we are still running the program in the background. If we press Q, dink, we've exited out.
Press any key to continue.
Actually, just for our sakes, we can put a C out here that just says
Here's what you pressed.
End of the game. I mean, outside of this loop.
Okay, I got you.
And then outside of here, we can actually say, see out.
Here's what you pressed. He's going to do that.
Here's what you... There's going to be a problem.
Oh, I can see it right now. And everyone else will see it very, very soon.
So, let's try to compile this. Oh my gosh, it didn't work. I wonder why.
Oh, see out.
Yes. So we're going to include IOStream. A few people do not know how to do this yet.
Yeah, and the namespace stuff.
Yeah, then I'm going to be very disappointed.
No, don't be disappointed.
I'm disappointed. All right, so if we press Control F5, nothing happens. We press J. Ha, here's what you pressed. J. K. Ding, 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 ding. Oh, no, don't want to do that. So inside of here, if we press Q, here's what you pressed. Q. End of game.
Hey.
So now we have polling data.
Yep, now we have...
And it's really that simple.
Yes, it is.
It is that simple.
So the next thing we need to do is create our timer update function, right?
Because what we're going to do now is control the rate at which our loops execute.
Right, because right now, it's running extremely fast.
It is running, although we can't see it.
We can't see it.
Extremely is an understatement.
You know what? I'm going to just...
Uh-oh.
Oh, jeez. Here
so
it
let's
comes.
see out.
Just
I haven't pressed anything yet. Hey, hey.
This will be great.
All right, so if I run this guy...
Yeah, let's see if you can... Now see if you can hit a key, and we can see it.
Dink.
Not Q.
Oh, my bad. Dink.
Look at that.
Oh, jeez.
And it all depends because we're recording at like 10 frames per second. Yeah, if you hold it down, you can still kind of see.
Yeah.
This is what Dan had mentioned earlier about the game being over in a fraction of a second. Mm-hmm. If we don't come in here and set it up so that we can control exactly how fast this loop's running.
Right. The AI would just come and we're dead.
Before you can even hit a key.
Yep. So let's get rid of this because I don't like it.
It was funny.
It was funny. Inside of here, what we're going to do is call timer update inside of the inside loop, right? Dink, timer update. So we need to define our timer update function. So we can come down here. Game. If anyone wants to add anything, please do.
No, I'm good.
Joel is typing.
Elevator music. Okay. So inside of here, what do we want to do? Well, currently, we don't really want to do anything, right? Currently we don't have anything to do. We don't have like our level, we don't have our character, we don't have anything to draw. We don't have the draw engine yet.
Right.
So there isn't really anything to do. But I do want to show you guys how to limit it. So first...
When you say limit it,
we
slow it down.
Right now, we're probably getting 5 billion frames per second.
Yeah. Actually, I'm going to prove it.
Okay.
All right.
Okay.
Continue.
But we want 30 frames per second.
Yeah, we want 30 frames.
That's all I was
That's all
you're going to make this seem like it's a much slower computer.
Yeah.
Exactly.
Back when video games were first coming out for the PCs.
Back in the day.
Back in my day. Typically, what you had was a very slow processor.
Yeah.
So you didn't have to worry about
it too much.
Limiting the speed.
Right.
And if you were to take a program that was made back in 1980...
Exactly, and run it today...
You won't be able to play it.
Exactly, because you'll be able to tell that they didn't care about the speed.
That's right. So inside of our game.h, I'm going to set up a few variables that we're going to be able to use. And I'll just set these guys up as private, because only
no
else is going to use
know
it.
About them.
We're going to say frame count. Basically, frame count is going to say every time we enter into the timer update, that's going to be 1 frame. So that means we're going to be updating 1 time, right?
Okay.
Then we have another double that's going to be start time. So the very first second that the program started, when it started. And finally, we're going to have a last time function, which basically is just going to take how long it was that... Well, you'll see in just a second, right?
Okay. I'll have faith in you, Joel.
Oh, okay. That's very reassuring, Dan. So inside of here, inside the timer update, we want to say frame count plus plus. So every time it's called, it's updated 1.
Incrementing that.
Right.
So if we were to print that in 5 seconds, we would have a very large number.
Yes, we would. Mega large
of
number.
How quick this is processing.
In fact,
right
why don't we just put this out at the very end? What did I call it? Frame count.
Frame count.
I knew that.
And just as soon as you get in there, hit Q. Ink.
Oh, okay. I did not initialize the variable.
Yeah.
That's bad.
That's probably
especially if you want to add 1 to it every time.
Yeah, exactly.
It's usually good to start at 0.
All right.
Start Q.
Dink. 32,821. So it was incremented that many times.
That's a lot.
That is a lot.
And about the second it took for you to hit Q.
Yep.
Yeah.
So that's really, really fast. So how do we get the current time of the processor? Well, there's a function, a Windows function called time get time. And we're going to use that. It returns to us basically the number of milliseconds since the computer started, right?
Yep.
So we can use that to calculate how long our program has been running. So at the very first we say, okay, what's the start time? How many milliseconds has the computer been on? At the end of your application, you check time get time again, and minus that by the start time, and you got the current amount of milliseconds that your program's been running. That makes sense, right?
Yes.
So inside of here we can say start time equals time get time, and it recognizes it. But
we will have to include some stuff.
Yes, we are. Check this out. If we do this, dink, time get time not found. Well, this is located in Windows.h.
Yep, which is platform dependent.
This is platform-dependent.
This is for Windows.
This is for Windows only. If you have if you're running with a different, what am I, operating system?
OS.
Thank you.
Like, say, one
Linux.
of the ones that Linux or one that's like a fruit.
Yeah.
Yeah. You'll have to do some research and dig up the call that you'll need.
Let's try this again. Reference not found for time get time. That's because we need to reference another library that our current project does not have. Don't worry too much about this, but what you need to do is go over to our project here, right-click, and go to Properties. Or you can go to File Menu Project, Properties. Dink, and it brings up the properties for your Evil Monkeys project.
Okay. Representing the student union out there, you've just blown my mind. We're in here coding. Life has been good up to this point. Now suddenly you're wanting to go off into these dialogues and property. What's going on here?
So basically what's happening here is, remember, we have a compiling and linking part, right?
Okay.
So at the linking stage, actually let me cancel all this real quick. When we compiled it, it said, oh, okay, Windows.h points at a time get time. So I must know where that is, right? Okay. When it gets to the linking process, which actually takes the functioning data and puts it in, right? It says, whoa, where's time get time?
And then it'll
I don't
search
know where it
through
is.
all of our source code and say, you didn't define it.
There's no time
here.
get time. So basically there's these libraries that contain references to where the code is.
Yeah, and we're actually already using some libraries.
Yes, we are using some libraries.
But we don't have to worry about it because they're standard.
Right. This one is kind of something that you need to tell the linker, here's where it is.
Yeah, because you don't want to link to a file if you
don't need it. If you link to a million libraries, your thing is going to be huge, and you don't need it to be. Does that make sense?
Yes, that's much better.
Okay. So let's right-click, go to our properties here, and to define extra libraries that we can link with, we can go to Configuration Properties, Linker, Input, and Additional Dependencies. What's this going to be? WinMM.lib.
Which
is the media library.
Media library. Because in Windows, media needs to deal with time.
Yep.
And so if you need a really nice, accurate timekeeper,
here's where to go.
This is where you go.
Whoa. Representing the student union out there, how do you know what header file? I mean, when you start getting into all this external stuff, I mean, I want to go out there and start building my own cool games like this and interesting programs. How did you, WinMM.lib? Did that fall out of the sky?
Check this out.
The neat part is,
Uh-oh.
with anything in programming, you're going to have to do a little bit of legwork and a little bit of research.
I know. Well, check this out.
If you don't know what's going on.
If you have time get time, right, you can click on it and press F1. This will bring up MSDN. This is a collection of the developer network, that contains all sorts of wonderful articles telling you how everything fits together and works. Well, it is context sensitive. If you click over time get time and press F1, it will search its database, its entire records, and say, there's this article on time get time.
Okay.
And it's going to bring up MSDN and say, ooh, check this out. We have information on time get time. The time get time function retrieves the system time in milliseconds. That's great.
But what if you didn't know about time get time?
If you didn't know about time get time, what you could do is search MSDN for time-related things.
Yeah.
Right.
Yeah.
And you're going to get a lot of results because MSDN is huge.
And this goes back to what Dan was saying then, because then you're going to have to do the legwork. You're going to have to start going through and reading to see what really targets what you're looking for.
Right. Just type in some key. It's like searching a library.
Right.
So we know if you know the concept of what you're looking for.
It's
in this
easier.
case, we want milliseconds.
Yep.
We want time information. It's easier to find what you're looking for.
That's right. So we could come down here in our time get time. And if we look down here, you'll notice it says library, use WinMM.lib.
Okay.
and it says to include Windows.h. So everything's cool. So let's exit out of this guy. And this is working good. If we try to compile this guy now, dink, linking, woo, successful.
Hey, it's good.
So it's good since we have WinMM linked to it. So now we know that's good. Now time get time is set. Now we can come down here and say cout time get time. So this is the end of the program. So how long have we been running? Time get time minus start time. This is going to give us how long our program has been running, right?
Right.
So we can say
at the very beginning, we grab the start time,
which say is 10.
Yeah.
And say we end the program at 20.
Mm-hmm.
20 minus 10 is 10.
Yep.
Which is how long we've
run the game for.
Yep.
So if we run this guy now, I just have time get time minus start time, and then I just print out milliseconds so everyone knows. Think, let's say 1, 2, 3, 4, 5, something like that. Think 5.321 milliseconds. So 5,321 milliseconds, which is 5.3 seconds.
Yeah.
Very simple. So, how do we calculate frames per second? In other words, how many frames have we updated every second? Well, that shouldn't be too hard. If we say, we know our frame count. Frame is frame count, right?
Right. And if we do per,
that means divided by. Frames divided by seconds. Well, we have time get time minus start time. This is number of milliseconds.
And we want to make sure we do the parentheses that Joel just did because of order of operations.
Right. If we did it this without, it'd be frame count divided by time get time.
Right. Minus.
Then minus start time.
Exactly.
So let's divide this as well because remember this is in milliseconds. So if we divide milliseconds by 1,000, that's going to give us seconds. So we divide that by 1,000 and that. You notice this is darkened. So this group.
It lets you know, what group you're working within at the moment.
Yep. So we can come into here and change this to frames per second. Dink. And we'll just delete this last line. So that should be good, right?
Okay.
So let's compile this. Everyone's happy. Let's run it. Dink. We are running at 39,906.1 frames per second.
Wow, if we could get that on some other video games.
Wow. Yeah. That would be awesome.
It would feel alive.
Mega alive.
So fluent.
But really, we only want this thing running at like 30.
Yeah, that we don't want what we have going on here.
Yeah, so we need to limit it.
Definitely. So let's go to our timer update function. Now, here's what we can do. We can say double, so we're declaring a local variable, and we're going to say current time. And it's going to equal time get time.
Again, our current time.
Our current time minus last time, which is the last time we got into this loop, right? But of course, have we initialized last time?
I haven't seen it.
I don't think we did.
So what we need to do is come up here and make sure that last time is equal to 0, right?
Again, this was what happened with frame count.
Yes, it is.
We did it. We had some garbly
just whatever numbers. Happened to be in that memory.
So time get time minus last time. Well, you know what? This value is going to be very, very small. Because think about it. We had 32,000 or something frames a second, right? So that means that every time this is run, what's time get time minus last time? It's usually almost 0.
Yes, but it will get bigger.
It will get bigger if we exit out of this and don't update last time. But at the end of this loop, what we want to do is say last time equals time get time. So at the end of the loop, we update with the last time we were in the loop.
Right.
So what we can say is if current time is less than a certain amount, let's just pick a number, 50 for now. If it's less than 50, in other words, time get time is maybe 0 or something like that.
Right.
Let's just return. Let's not do anything. Let's not update on this. Let's wait a few more milliseconds or whatever.
Before you move on, though, Joel, I want you to look at line 49.
Aha.
Oh, there you go.
Yeah.
I hope everyone out there
caught that. Very funny.
Or looked away when Joel did it anyway.
Nobody saw that.
No one.
So inside of here, if current time is less than 50, it's just going to return. So frame count is not going to update until current time is greater than or equal to 50, right? So if we compile this guy, and let's run him. Let's just give it a few seconds.
1,
2, 3. Yeah, okay. Dink. Here's when you press. Now it's down to 20.1 blah, blah, blah frames per second.
Yeah.
So we have limited it. Well, think about it. Let's say we want 30 frames a second, which is what we want.
Right.
How do we get 30 frames a second? If we want 30 frames a second, that means 1,000, which is how long? 1 second. We want it to be 30 frames, right?
Yep.
That means that we want to run update every how long? Well, 1,000 divided by 30 is 33.33333, up to infinity.
Right.
So every 33.33333 milliseconds, we want to update, which will give us about 30 frames a second. So let's delete this guy. That means if we change, where was I? Excuse me, right down here to 50. If we change this to 33.3333, or if we change it to that, we should get around 30 frames a second.
Let's find out.
If we run this, and let's just give it a few seconds.
2,
3,
4,
5,
10,
20,
30.
I'm confused.
Okay, dink. Look at that. We get 29.42, very close to 30 frames
close,
a second.
Yeah.
So now we've successfully limited it to be exactly the right amount we want. One more thing we should do, though, is create a define statement so that we can change the game speed whenever we want to.
Yeah, this is just for easier programmability.
Right.
You can keep all your variables that you might want to change in one place at the top of the program, and then when you change that variable, it'll filter through the program because you use that variable in the rest of your program.
That's right. So what we could do here is just do a simple define statement called game speed. Speed. And we can define it as 33.3, which is going to give us, let's actually put that. This is going to give us 30 frames per second.
Perfect.
30 fraps per second. That'd be pretty tasty to me.
Yeah.
Or, chocolate frap.
Sure.
You know what a frap is?
No.
You don't know what a frap is?
Okay.
Oh.
I think of frappuccinos.
Yeah, that's what I think of too.
I was thinking
like
chocolatey.
Okay.
Yeah. Kind of what a frappuccino is.
So game speed is now defined as 33.3. If we compile this and run it, give it about a second, exit out, we get about 29.7 frames a second.
Great.
Then our end of game. So that successfully basically creates our game class and limits it so that it doesn't go too fast or too slow.
Okay. Now let's do a recap.
Okay.
Because there's a lot of things that you went through. Basically, you've made a total of 3 different files throughout this lesson.
Yep.
We did the main.cpp, and it was explained earlier that it's pretty common.
Yep.
It's a convention.
It is very common.
Because that's where you're going to find your main function. Okay. And then we defined both the header and the CPP file for game, which, as explained at the very beginning of this lesson, is the heart and soul of our whole game beast, if you will. Without it, well, the game just doesn't function, doesn't run, doesn't go, no playing. Period.
Yep.
And the whole idea of the game was to provide the game loop, again, found in most all games.
That's right.
And the looping, in the end, is going to be doing 2 things if we wanted to make it as simple as possible.
Yeah.
Looking for input from a user so that we can then work upon that.
Right.
And updating our screen. And we've now got it set up so we can take input from the user. Now, to make it a little bit more involved, we've also used game to control the speed of which our game loop's going to run.
Which is very important.
Which is critical these days as computers have gotten so fast that without that, you guys already saw that we were running thousands of frames per second, which means that all of our little creatures and everything would be able to run around so fast and get you before you could even recognize what was going on the screen.
They would
let alone make it to a key.
You get the press the key to continue.
Exactly. Game over.
Game over.
Yep.
And with that really starts us out with a base foundation for our game. So that's going to wrap up this lesson. Thanks a lot, everyone.